Hi again, everyone. In this next section, we're going to talk about formulas. I'm going to divide the lecture information into two parts. There's a list of formulas that you should download as well that are posted online. So here we go. A common formula that gets used a lot in math class is the formula for, say, the perimeter of a rectangle, the distance around a rectangle. And a rectangle has 4 sides and 4 right angles. And often one of the sides is called the length and the other side is called the width. And one of the properties of a rectangle is that opposite sides have the same length. And so however tall the left-hand side of the rectangle is, the right-hand side has that same height, and the bottom and the top, the way I've drawn the picture, they have the same height. And so the perimeter, the distance around the rectangle, if you were to walk, say, from point A to point B to C to D and then back to A, you would walk the length plus the width plus the length plus the width, which is often abbreviated L plus W plus L plus W. And the right-hand side has only addition in it. And so we may change the order of the terms. And L plus L is the same thing as 2 times L. And W plus W is the same thing as 2 times W. So the way you should think about the perimeter of a rectangle is in words. The perimeter of a rectangle, you just add up the lengths of the 4 sides of the rectangle. But oftentimes in a textbook or something, the formula will be written, instead of in words, it will be written algebraically, and it will be written in simplified form. So suppose we are using this formula. Remember, a formula is an equation with more than one variable in it. And usually one of the variables is all by itself on the left-hand side of the equation. Oftentimes, we see problems like this. So if L is 8 and W is 3, Find P. So first, we're going to copy down the formula. Always, 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 in this class and every class, whenever you are about to use a formula, always write the formula down first. This formula has 3 variables in it, P and L and W. If we know 2 of them, we can find the 3rd one. So they're asking us to figure out P when we substitute 8 for L and 3 for W. And we know we need to do both of the implied multiplications before we add. So we can actually do both of them at the same time because they're the same kind of operation and they're separated by addition, which comes later. So when P is 8 and when L is 8 and W is 3, then P is 22. And I'm sure that you have done these kinds of problems before. We could pick different numbers. If L is 5 and W is 17, find P. Well, we're going to start with the formula. P equals 2 times L plus 2 times W. We'll substitute in the given numbers, and then we'll follow the order of operations. We have to multiply before we add. And we get a result. Sometimes the question you are given is a little bit different. Maybe the question is similar, using the same formula, but maybe the question is, if P is 22, and W is 3, find L. Well, in this case, one of the numbers they're giving us is the P, and this time it's the L that's the unknown number. And so, yes, there's a little bit of arithmetic we need to do. 2 times 3 is 6. But the variable that is the missing number is not the variable that's all by itself in the formula. So after we substitute and do a little bit of arithmetic, now we need to do algebra to get this L all by itself. L is only on the right of the equal sign. L is being multiplied by 2, and then we're adding 6. So we can subtract 6 from both sides. So 16 would be equal to 2 times L. And then to undo the fact that L is being multiplied by 2, we're going to divide both sides by 2. And we're going to do that in a new step. And so now I have 8 is equal to L. And usually we like to have our variable on the left when we're all done. So we'll write L equals 8. And equations are symmetric. If one thing is equal to a second thing, then the second thing is equal to the first thing. So I used some of the same numbers in this problem as I did in the first problem, but this time the missing number was L instead of P. And I could do the same kind of thing with the second problem, the B part of the problem. I could give you P, and maybe I'll give you W again and ask you for L. So if W is 17 and P is 44, find L. So we're going to start with the formula that we are given. We're going to substitute in the 44 everywhere we see P and the 17 everywhere we see W. 2 times 17, we can do that multiplication. But now to find L, we have to do some algebra because the L is not all by itself. Just like in the previous problem, we'll undo the addition first with a subtraction. And then we'll undo the multiplication with a division. And this time we end up with 5 equals L. In other words, L equals 5. But now we're going to put a little twist on these questions. If P is equal to 2L plus 2W, solve this equation for L. So what they are asking us to do is to take the formula that right now has P all by itself and to do the algebra to rewrite this equation equivalently, but with L by itself. So we're going to pretend that we have a number for P and W. We're going to pretend that P and W are constants, even though they really are variables. And then we're going to try to get L all by itself. So in the previous problem, I told you that P was 44 and W was 17. And after we multiplied the 2 times the 17, in order to get L by itself, we subtracted the 34 from both sides. And that gave us, I'm going to write it this way, 44 minus 34 equals 2 times L. In other words, we had 10 is 2 times L. Then we took that equation and we divided both sides by 2. And so we ended up with 5 is equal to L, or L is 5. So the idea is that we're going to sort of be doing the exact same thing, but only pretending that we have numbers for P and W. I'm going to copy this equation, this formula down so that it mirrors the previous problem. Once we had 44 equals 2 times L plus 34, we undid this addition with a subtraction. So that's what we're going to do over here. L is being multiplied by 2, and then after that, something is being added to 2 times L. So we're going to undo this addition by subtracting 2W from both sides. We'll bring the equal sign straight down. The right-hand side is now 2 times L plus 0, so that's just 2 times L. On the left-hand side, we're starting with P, and we're trying to subtract 2 times W. But those aren't like terms. We can't actually do the subtraction. What we can do is write down that we're supposed to do the subtraction. Over here, we were able to actually subtract 34 from 44 because those were both constants. But P minus 2W, the left-hand side can't be simplified this time because I don't actually have numbers for P and W. I'm just pretending as if I did. So in the previous example, we were able to say 44 minus 34 is 10, but in this example that we're doing now, we can't actually do that subtraction. So I'm just, again, to stay parallel with the previous example, I'm just going to copy it down again. And then we had to say to ourselves, self, we're trying to get L by itself. L is being multiplied by 2. So to undo multiplying by 2, we can divide by 2. And on the right-hand side, then we'll have 1 times L, which is just L. On our left-hand side, we had P minus 2W. And if we divide by 2 on the right, we also have to divide by 2 on the left. But again, since we don't actually have the numbers, for P and W, we can't actually do any of this arithmetic. Now we have L all by itself on one side of the equation, and on the other side of the equation, there aren't any L's. But since we're trying to get L by itself, when we're all done, we prefer to have the variable on the left. So we can just swap or switch the left side and the right-hand side. Now, we have to be a little bit careful with this left-hand side, because we see this 2 in the numerator and we see a 2 in the denominator, and it's very tempting to want to divide them out. But remember, when we simplify a fraction, we have to divide out common factors. And so the numerator would have to be 2 times everything else in the numerator. But right now, only the W is being multiplied by 2. And then we have a subtraction in the numerator, which is an addition in disguise. But if you have addition or subtraction in either part of your fraction, that means that you don't have the numerator factor, right? If it's prime factored, it would be something times something times something times something, however many factors it has. This isn't something times something times something times something. It's one thing, P minus something. So 2 is not a factor of the numerator. So we cannot say, we cannot just cross out the 2's and write P minus W. Because there's not, the numerator is not written only as a product. Now, if all we want is to get L, that variable by itself, we're done. Sometimes when you solve these equations, one person's answer might look a little different than another person's answer. For example, think about subtracting fractions. When we subtract fractions, we need to have the same denominator. The denominator stays the same, and then we subtract the numerators. And this fraction has a single number in the denominator, and it has a subtraction in the numerator. So we could write that this new equation is equivalent to the one we just had written. And in the second fraction, now 2 is a factor, because in this fraction all by itself, the numerator is 2 times something, 2 times W. So once we have L by itself, we may stop here. Someone else may have written the problem, some of the intermediate steps slightly differently, or they may have decided for whatever reason that instead of having a single fraction on the right-hand side, they want to have separate terms on the right-hand side. And then they noticed that in the second term, the 2's were a common factor. So when you are doing these kind of problems, if your answer looks different than somebody else's answer, or the answer in the back of the book, see if it's one of these situations in particular, because whenever an answer is a fraction, remember every fraction has infinitely many names. And a single fraction, if there's addition or subtraction in the numerator, maybe it started as two separate things that were being subtracted. So sometimes it's easier to take your answer and to try to make it look like your friend's answer or the answer in the back of the book. Other times it's easier to take your friend's answer and see if you can make it look like your answer. Oftentimes in our science classes, especially when there's a formula involved, we often have to do a problem like problems C and D, but not just for two different sets of values for some of the variables, but maybe 50 different sets of numbers for those two variables. And each time we have to figure out L. Well, whenever you are doing the same computation, but just different numbers, that's what computers were built to do. And in particular, spreadsheets can do that work very, very quickly. They can do a whole bunch of arithmetic in just a second or two. But most computer programs don't know how to do any algebra. So if there's some general formula that applies, but we're going to be doing a problem like C or D over and over and over and over and over and over and over again for different pairs of numbers of P and W, it's helpful instead to do the algebra first, to take the formula and rewrite it so that instead of P being by itself in the formula, a different variable is by itself in the formula. And then, yes, somebody has to enter in every pair of numbers for P and W, but that's just a typing skill. And then once we've entered every pair of numbers, we only have to type the formula essentially once, and then we can just copy that formula into however many rows in our spreadsheet that we have, and the computer will calculate the value for L for each of those, say 50 pairs of numbers P and W. So in the next video, we're going to do more problems like problem E, but we're going to start with probably do this problem again, and then we'll do some other problems involving other formulas.